Hello everyone, my name is Equinox407 and welcome to the introduction to Grand Theft Auto weapon modding. In this video, I'll be teaching you how to port any 3D weapon model into GTA 5 and animate it. I'll be covering everything I know, so this will be quite a long video. Feel free to skip to any part you're interested in. Timestamps will be in the description below. The topics in this video are: convert 3D models to the WIDIA format for GTA 5 to use, animate weapons properly, identify how materials and shading work in GTA 5, adjust the position of weapon attachments, edit the position of iron sights and fix various errors and issues. The things you will need are a 3D modeling program like 3ds Max or Blender, GIMS Evo for GTA 5, ZModeler 3 and OpenIV. Before I start, you will need some prior knowledge. I won't be explaining how to use 3ds Max or Photoshop, but I will be explaining my process in them. With that said, let's begin. Part 1. Setup. First thing we're going to do is open OpenIV and find the weapons.rpf folder. The fastest way to do that is to open the search by pressing Ctrl F3, then type the weapon's name in full. For example, if we want to replace the carbine rifle, just search W_AR_carbine rifle.ydr, then right-click on the one not in the mods folder. It will be underneath the one highlighted in blue under the patchday8ng folder. Simply right-click, then click Go to File. Once you found the weapon model you want to replace, click on Edit Mode at the top, then copy the weapon name and paste it into the search at the top right. After that, highlight all the files and drag and drop them to a new folder. To make this process easier, copy the folder location at the top. Highlight all the models and right-click, then click Export to Open Formats. Save it to any folder you like. Once the model is done extracting, open 3ds Max. On the right, go to the Utilities tab, then click on the far right icon in the GTA 5 section at the bottom. Click Import, then select the .odf file we just created. Make sure you select the high model. Just close the window, then double-click on the model hierarchy and click on the weapon model while holding down Ctrl, then press Delete. Now scale down the model to the size of the gun you imported. Try to match it up as best you can. Remember to save your work. For scopes, you want to separate the glass and reticle from the model itself, as they all use different materials. After that, highlight your entire scene by pressing Ctrl A. Then, while holding down left-click, deselect the magazine, any attachments on the gun, and the bullets if your magazine contains them. Click on File, then select Export Selected and choose a location to export your model. Next, change the file type to .obj and click Save. Copy the settings displayed on the screen and then click Export. Now export the magazine and bullets if you have any. You want the bullets to be separate from the magazine if they use different textures. We will be attaching them together in ZModeler. For my weapon, the bullet textures are a part of the magazine textures, so I don't have to worry about that, but I will show you how to add materials and attach the bullets to the magazine later. Now you can export the attachments. Highlight your attachment and delete the rest as it is not needed. Then import the model you will be replacing. In my case, I will be replacing the carbine rifle scope, so I will need to import the scope_medium model. Make sure to import the high model. Now select the model and delete the rest. Then line up your scope with the model we just imported and export it once you're finished. Repeat the same process for any other attachments, like grips. For the foregrip in GTA 5, it uses an angled grip model, meaning your character places their hand over the left side of the model. If you position your model towards the left, it will clip through the hand, unless you adjust the position of the attachment. Part 2. Animating weapons. Now on to ZModeler. First import the gun you will be replacing, then import your model you just exported from 3ds Max. Some quick controls include holding the middle mouse button while dragging to pan, and holding the left shift key while left clicking to look around. To toggle the model, click on L0 on the top left. To make things easier, zoom in on all the viewports. Then click on the plus icon to expand on the hierarchy. Now import your model to ZModeler. When you import any 3D model into ZModeler, it will be assigned a default material that is simply white. To remove this, click on the material browser at the top of the screen, then highlight all the materials and click delete. In ZModeler, you cannot delete the first material no matter what. It will not let you. If you want to delete it, simply move it to another position in the material editor, and then it will let you remove it. Now that we have removed all the materials in our scene, we are going to create our own. To make things easier, you can copy the names of your textures so it's easy to keep track of which materials have textures for each part of your model. Click on New to create a new default material, then name it however you'd like. Once you're done naming your materials, click on the globe icon at the top of the screen, then navigate to GTA 5, Weapons, and weapon_normal_spec_detail_palette. This is the material that weapons use in GTA 5. Now click on the icon next to the material browser. This is the texture browser, which shows all the textures in every material in the scene. We want to remove all the GTA 5 textures except for the environment map and the environment smooth concrete map, as these two are needed. Click on Add to include your own textures. Once you've added them, you'll notice that all the textures are in lowercase and do not have any uppercase letters. This is merely cosmetic and will have no effect on your mod. Personally, it bothers me, so to fix it, all you need to do is replace your textures with the same ones, and the names will display correctly. Once you've added your textures, double-click on the material to open it. Detail 1 will be your base color. Detail 2 will be the environment smooth concrete map, and Detail 3 will be your base color again. The bump map is your normal map, and you can ignore the mask. The spec map is self-explanatory and is sometimes called a metalness map. It determines which parts of the model are shiny and which parts are not. The environment map is the material we saved at the beginning. When you add the environment map, it will make your model look strangely chrome. To fix this, tick the box on the left, then select the spec map under Affected Map or Channel. Now it should look good. Simply repeat the process for all the materials you have. Now we're going to apply the materials to our model. To make things easier, select the model hierarchy, then click on the square to the left to hide the other elements. We only want our model to be visible for now. Click Isolate to hide all other models, then click on Polygon at the top of the screen. Click on the model again to display all the vertices. Press Shift-A to highlight all the vertices. Under the Scene Nodes browser, click on Properties, then click on the plus icon next to Polygons. Under Material, select the material that matches that part of the model. Click on Object to exit editing the vertices. As you can see, the model now has the correct textures. Repeat the same process for the rest of your model. Now our model is fully textured with the correct materials. To join the parts of the model together, click on Isolate, then under the Modify tab, click on Attach. Make sure you're in object mode when attaching models, and not in polygon mode, as it will not work otherwise. Click on the model you want to attach, and then on the right side, click on the other part of the model you're trying to attach it to. It will then be displayed, and when you click on it, it will be attached. Simply repeat the same process for the rest of the model. As you can see, our model is now fully textured with multiple materials under a single model. This is the fastest and easiest way to do it. Now we're going to animate the gun. First, isolate the main components of the gun, then click on Dismiss. This will discard compound nodes and convert them to separate nodes, meaning the mesh will be removed and will no longer be linked to any animations. You will need to unhide all elements in the scene. Once you've done that, simply delete the old mesh and repeat this step for every animated part of your model. Now click on Gun Main Bone and select Isolate. Deselect Attach, then under Display, click on the hand icon. This will copy the axes from one node to another. Next, click on the Gun Main Bone node, which appears as a box in the viewport, and then click on your model to copy the axes from the node to your model. Click on L0, then click Convert to Compound. Click on the lock icon, then click on L0 again and drag your model to the gray box. Then click on the lock again and click on L0 one last time. Now, when you toggle L0, it will hide and unhide the model. Simply repeat this process with all the parts of your model you want to animate. Now we are done animating the weapon and you can save your work. ZModeler sometimes takes a while to save, so just be patient. We are now ready to export the mod. To start, copy the original game files to a new folder where you will export them. Simply drag and drop the game files into your new folder. I already have the files in this folder, so I will be replacing them. Make sure to copy the files from the base game and not your mods folder. For now, you only need the models, not the textures. Now click File, then Export and find the folder where you just copied the game files. Click on the low model, then click Export and select Yes. Next, add an underscore high, delete the collision, and re-export the model. Now onto the magazine. Right-click on the WAP underscore clip, go to Linking, and then click Unlink. After that, delete the rest of the mod as we only need the magazine node. Import your magazine and remove the default material. Then, import the original magazine and isolate the magazine node. Copy the axes from the node to your magazine. Now click on the hand icon, unisolate the magazine, and delete the magazine node. To fix the textures, click on Polygon mode at the top, then select all the vertices by pressing Shift-A. Go to Properties and change the material to your magazine material. Then go back to Object mode and remove the GTA 5 magazine material and textures. Drag your magazine to the bottom, then hide the game model. Click on Modify, then click on the Move tool. In the top left viewport, move your magazine to the dot on the screen. Make sure the viewport is set to the back view. Try to line your magazine up with this dot as best as you can. Also, remember to align it in the left view as well. Once that's done, expand the model hierarchy and click on AAP clip. Then go to Structure and repeat the same process as before, but this time we don't need to copy the axes from the nodes. We already copied the axes from the magazine node we deleted earlier. Now you can export your model. We're going to make one last save, this time saving the magazine. Now we can import the textures. Go to your mods folder and paste your weapon name into the search bar. Then drag and drop the gun and magazine we just exported into your mods folder. As you can see, our model is now visible in OpenIV, but it doesn't have any textures yet. To add the textures, simply right-click on the texture file and click Edit. Now delete any textures and import your own. For the base color, only set the texture format to the one on screen. The rest will be automatic. Once you're finished, just click Save. Now drag your texture file to the folder with your model, then make a copy of it and remove the +hi at the end of the file name. Then move the texture to your mods folder. For the low textures, you want to set the resolution lower than the high. In my case, the low textures will be 1080p and the high will be 2K. Simply replace all the textures with the lower resolution ones. Then just replace the old low resolution texture with the one you just edited. Now the textures will be visible on your model in OpenIV. Repeat the same process for your magazine. This time, you only need the magazine and bullet textures if you have any. Now your gun should be working in the game. As you can see, it's fully animated. This is what it will look like if you don't adjust your attachments. They're completely out of place. I'll show you how to fix them now. Part 3, Fixing Attachments. Fixing attachments is quite easy. To get started, simply select the model hierarchy and hide everything except your model. Then unhide the nodes you're trying to move. I will use the gun VFX Eject as an example. Go to the Modify tab at the top and click on Move, then go to Create and click on Copy. Click on the X at the bottom left corner to move only along the X-axis. Now, when you move the node, it will create a copy. Click on Copy again to exit, then go to Display and click on the hand icon. Click on the new node we created, then click on the old one. This will copy the axes from the old node to the new one. Then simply drag the new node on top of the old one. This will group them together. Now the nodes will appear as one, and when you move one, they will move together. You can now freely move your node wherever you'd like. In my case, I need to move the node further to the right, as I moved it too far to the left. For the muzzle and suppressor, it is the exact same process. However, there are a couple of things to keep in mind. The muzzle VFX node needs to be at least 11 spaces ahead of the end of the model itself, and the middle of the suppressor node needs to line up with the beginning of the muzzle. As you can see, I am trying to line up the node to the center as much as I can, and it is about 11 spaces ahead. The flashlight is the same as the other attachments, as the center is about where you want to line up the node with the rail. As I mentioned before, you want to line up the center of the suppressor node with the beginning of the muzzle. This will ensure that the suppressor fully covers the muzzle. The scope is the same as the others. Just line the center of it up with the rail. Sometimes you might have to adjust its position though. It's all about trial and error. And finally, the grip. Just repeat the previous steps. In my case, the grip node already lines up with the rail, so I don't have to adjust it. We have now finished editing the attachment positions, and we can see what they look like in the game. Simply export your model as we have done previously. Now the attachments align perfectly with the rails. If they don't look right in the game, just keep adjusting them in ZModeler until they do. Part 4. Adding scopes. Adding scopes follows the same process as before. To start, click File and then import the scope you will be replacing. As I mentioned earlier, I will be replacing the carbine rifle scope, so I will import scope_medium. Now import your model and delete the default materials. Then delete any previous materials. We will just replace the textures since it is faster. See how each material affects the model. There's one for each part: the scope, the lens, and the reticle. When I toggle one, it will be hidden in the viewport. The scope will use a normal material, but the lens will use a material with an alpha channel. As for the reticle, it uses an emissive material. An emissive material will make the texture glow. Each material will affect the intensity of the glow and properties, such as whether it only glows at night. To make things easier, I'm going to rename the materials to keep track of them. Now remove the old material, then go to the texture browser and delete all of the unused textures. After that, simply replace the game textures with your own. Your lens texture will need to be a PNG with an alpha channel for transparency. Make sure the opacity is around 40 to 50%. You can adjust it if needed. Now I'm going to add the reticle texture. The lens texture is a part of the scope texture, so I don't have to add it. After that, simply replace the material textures. It is the same process as with the gun itself. The scope should already have the correct textures, but you will need to replace the reticle if you added it as I did. As I said before, the lens texture is a part of the scope texture, meaning I only need one material. The texture simply needs to have the lens be transparent. You can see the texture in the browser here, and you can also show the transparency. If it appears invisible, then the texture is correct. Now we can animate the scope. First, make sure your materials are correctly applied to the scope, or it will not display correctly in GTA 5. As I've mentioned many times before, the process is the same. Just repeat the steps you've already done. Simply change the materials and attach the models. Once you're finished, just save your work, then export the model. Now copy your mod to the game and import your textures. If done correctly, you should see that the lens is transparent in OpenIV and the reticle will be visible. You may see a square in the background of the reticle. This can be ignored as it will not appear in-game. As you can see, the scope works perfectly. The reticle glows and the lens is transparent like glass. Part 5. Fixing iron sights. As you can see, when I go into first-person view and aim my weapon, the sights don't line up. This is because the first-person scope offset coordinates are incorrect, as we replaced the original gun with our own. To fix this, you must edit the weapons.meta and change the coordinates. Go to search and type weapons.meta. The file we want to edit will be located under Common Data AI. Right-click on the file on screen, then click Go to File. After that, right-click on the file and select Edit. Go to search and type the text on the screen. This will take you to the weapon information. Simply click on the down arrow to navigate to the next result. Keep clicking it until you find your weapon. Once you have found your weapon, scroll down until you locate the first-person scope offset. These are the coordinates you want to edit. The letters represent the coordinates in 3D space. You can use the 3D view to get a better idea of how to edit the coordinates. In my case, I need to move the sights down, so I will edit the Z coordinates. You'll want to adjust the numbers in small increments. It'll take some tinkering to get everything just right. To make this process easier, I'm going to copy this line so I can find it instantly the next time I edit the weapons.meta. Just click Save when you're done to exit. As you can see, my sights now line up in first person. It's not perfect, but it's much better. The same process applies to editing the sights for attachments as well. Part 6. Adding flashlights. Flashlights are really simple to mod. First, import the flashlight you're going to replace, then import your model. In my case, I'm replacing the carbine rifle's flashlight, so I'll import the AR_flash. After that, remove the default materials and any unused textures and add your own. The process is the same as with all other attachments. The bulb is not needed when replacing the flashlight, so you can simply dismiss and delete those models. Now copy the axes from the node and click Convert to Compound. The rest of the steps are the same as before. Once you're done, hide everything in the scene except for the flashlight and the muzzle node. The muzzle node is where the beam of light originates. In the top left viewport, click on the Move tool, then move the node to the right to create a copy. Finally, drag it on top of the other muzzle node. You might be wondering why I didn't make a copy before moving the node. That's because technically you don't have to, since it will work in game. However, it's best not to take any chances. So in any case, just align the node with the reflector. Then save and export your work. If you did everything right, the flashlight will look like this. Remember, if it doesn't look right, you can always adjust it in ZModeler. Part 7, Adding Glow Sights. This section will be very short because it's extremely simple. First, import your model and delete the default material. You'll want to separate the glow sights as they will use a different material. Click Isolate and open the material browser. Then, create a new material and name it. After that, click on the globe icon, hover over GTA 5, and under Emissive, click on Emissive. Simply select your texture, then apply the material to the glow sights. You can use either a solid color or a texture that includes the glow sights. In my case, I'll be using a solid color. And that's how you add glow sights to weapons. It's very simple. Part 8, Fixing Normals. When creating weapon mods, you may notice that some parts of the gun appear invisible in game. This occurs due to the normals. When this weapon was modeled, the interior was created after the exterior shape, which means the internals of the receiver are facing the negative side of the normals. As a result, this area of the weapon appears invisible during gameplay. You can identify a negative normal because it will appear dark red in 3ds Max. Unfortunately, you can't simply fix this by flipping the normals, as the mesh is one-sided. If you flip the normals, the exterior of the receiver will become invisible. Notice how when I click on the inside of the receiver, it turns dark red on the inside but light red on the outside. This difference is what causes the interior of the gun to appear invisible. To fix this, simply create a copy of the receiver and delete any unnecessary parts. Next, highlight the entire mesh and click Flip. Make sure you are in polygon mode or element mode. As you can see, the interior is now light red while the exterior is dark red. This resolves the normals issue. Simply export the flipped receiver you just created. Now, let's move on to ZModeler. Start by opening your project and importing the model you just exported. Next, delete any default materials and assign the receiver texture if needed. Then, drag the receiver over the main gun bone and release it. It will move to the bottom of the hierarchy, so make sure it's positioned under the main gun bone or the animations will break. Once you're finished, simply export the model and you're done. As you can see, there are no longer any invisible parts. Part 9. Scope Reflections. When creating scope mods, you might notice that the lens isn't very reflective. While it may appear shiny, it doesn't display real-time reflections. To add reflections, start by importing the model you want to replace. As you can see, when I toggle the material in the browser, it hides the texture in the viewport. Keep toggling the materials to identify which one corresponds to the lens and which one corresponds to the scope body, and rename them accordingly. Finally, open the texture browser and remove any unnecessary textures. Next, select your textures as usual. Then, scroll to the top and change the source to source alpha and the destination to inverted source alpha. After that, open the lens material, select your lens textures and import your model if you haven't done so already. Next, delete the default material and replace the scope with your custom one. The process is the same as usual. Be sure to apply the lens material to the lens and vice versa. If done correctly, the lens of your scope should look like this. It now has real-time reflections and a shiny finish. The only issue is that it's too reflective, so we need to adjust it. To edit the lens, open the material browser and double-click on the lens material. Scroll down to the bottom and adjust the level on the spec map. The more you decrease the spec level, the more the base color will show through. In my case, I'll set the level to 50. Keep adjusting the level until it looks right. Once you're finished, simply export the model and install the files. As you can see, the lens looks much better now. It's darker, more realistic, and the base color shows through more clearly. Part 10. Shell Ejections. Editing shell ejections is straightforward. The shells always eject along the x-axis. First, hide everything in the scene except your gun and the gun's VFX eject node. Use the Move tool to create a copy of the VFX eject node, then copy the axes and group them as you normally would. Now, adjust the node to your preference. In my case, I want the gun to eject shells from the bottom, so I'll use the rotation tool to rotate the node 90 degrees. Remember, the shells will always eject along the x-axis. Once you're done, simply export your work and copy the files to the game. Notice that the shells now eject from the bottom of the gun instead of the side. If they're ejecting from the wrong side, simply adjust the VFX eject node in Z Modeler.
I'm out.
Part 11. Adding collision. As you can see here, the gun disappears when I shoot the NPC. This happens because the gun lacks collision, so instead of being dropped, it vanishes. Luckily, this can be fixed. There are two methods to restore collision, and I'll show you both now. First, find your model in OpenIV, then select the low model, right-click, and choose Export to Open Formats. Choose a location to export your model, then proceed with the export. Next, go to the original carbine rifle location and export it as well. Remember to export only the low model, as the high model does not use collision. The high model is what the player uses, while the low model is what NPCs use. Now, go to the folder where you just exported the carbine rifle and open the folder inside labeled W_AR_carbine rifle. Next, copy the .bound file and paste it into your weapon folder. Then, return to the carbine rifle folder, right-click the .odia file and select Edit with Notepad++. If you don't have Notepad++ installed, you can also open this file in OpenIV. Simply copy the line that starts with bound at the bottom of the screen and paste it into your weapons.odia file. This will restore the collision. The last step is to import your weapon into OpenIV so it can be used in-game. Right-click anywhere in OpenIV and select Import Open Formats, then click on your weapons.odia file to import it. The file will automatically be converted to a .ydia model and will be ready for use in-game. As you can see, the gun now has collision and will drop to the ground. This also resolves any floating magazine issues you may have been experiencing.
Why hasn't someone sensible shot you yet?
Now on to the second method. This method is very simple and slightly faster. All you have to do is import the original game model you're replacing and take the collision from it. To start, simply import the original game model into Z Modeler, then click on the plus icon. As I mentioned earlier, make sure to import the low model and not the high, as the high model does not have collision. Drag the .collision over the root folder and release. Now your model will have collision when you export it. Just be sure to delete the collision when exporting the high model. I'm going to delete the carbine rifle materials and remove the textures before exporting it. Part 12. Fixing meshes. When you import a model into ZModeler and attach the mesh, sometimes it can explode, causing the vertices to scatter completely out of place. This happens because ZModeler has a polygon limit, and going over this limit will break the mesh. Here we can see the mesh explodes when I attach the receiver to the gun. I'll show you how to fix this now. First, copy the axes from the gun main bone node to both parts of your mesh. Then, convert only one of the parts to a compound. Next, drag the other part onto the gun's main bone and release. This will move the model to the bottom of the hierarchy. Make sure it is placed under the gun main bone and nowhere else, otherwise the animations will break. As you can see, the mesh is intact, and when we export it, it will remain unbroken. Part 13, Shading in GTA. As you can see in the video, the shading on the gun looks off. The metal parts are too reflective, while the wood has no reflections at all. This isn't usually what you want. While wood, rubber, and plastic aren't highly reflective, they aren't completely devoid of shading either. Unlike Red Dead Redemption 2, GTA 5 doesn't use physically based rendering. Instead, it was built on an older version of the Rage engine and relies on just 3 textures for materials, a base color, a specular map, and a normal map. This setup means you don't need to worry about ambient occlusion or roughness textures. As you can see, my gun has a wood texture, which means I need to adjust the spec map to get it just right. Non-metallic objects should be dark grey, indicating a balance between shiny and matte. Black means no specularity at all, while white represents 100% specularity. For guns, you want to make the wood and plastic parts grey and the metal parts a light grey to dark white. To edit the spec map, simply open it in your preferred editing program. For this demonstration, I will be using Photoshop. Start by clicking on Select, then choose Color Range. Click on any white part of your texture, set the fuzziness to 100 and click OK. Next, go to Image, then Adjustments and select Exposure. Set the exposure to a value between -2 and -2.4. After that, right-click and choose Select Inverse to invert your selection. Now go back to Exposure and set the offset to 0.04. As you can see, the spec map is now grey and light grey instead of black and white. It is ready to be exported and used in the game. Now the gun looks much better. The wood has depth and the metal isn't overly shiny. It looks just right. If it's still not quite there, you can keep editing the texture until it looks perfect. It just takes time.
I gotta reload.
Part 14, Fixing normal maps. When downloading models, you may encounter some with unusual textures like this. They appear this way because they use a different format that only the game engine can interpret. GTA 5 uses an RGB format similar to physically based rendering, so the normal maps must have the purple color you're familiar with to work properly in the game. I'm going to use a program to convert the texture to the correct format. It's called Normal Map DA Converter and was originally created for Dragon Age mods, but it works with any textures that need converting. Simply open the program, click Open, and locate your texture. Make sure you select all files to display all available textures, as your file might not appear otherwise. Next, click on DA2 and set the output to RGB. If it doesn't look correct, try changing the input to DAO instead. Now click Save, choose a name, and select a location to save the file. The normal map will now appear purple and will be usable in the game. And that's it for the video. I hope you enjoyed it and learned a lot. If you have any questions, I'll do my best to answer them in the comments. All the software and resources used in the video will be listed in the description below. Thanks for watching.